This video is going to cover Learning Target 1 of Unit 2. We're going to see some straightforward examples as well as some ones that require a little more thought. All of these problems have the same starting question. Find the nth term of the following sequences. So for all of these, we're going to have to first determine if it's arithmetic or geometric so that we know what formula we are using. Okay, sometimes I will tell you, find the nth term of this arithmetic sequence. But for these ones, I don't specify what type of sequence it is, so we just need to figure it out ourselves. So looking at this first one, we've got 3, 7, 11, 15, 19. Looking at this, I can kind of just see that the rate is seemingly constant, right? It looks like it's going up at about the same amount, right? It's not like 3, then 10, then 100, then 300, right? Where it's kind of the jump looks like it's getting bigger. Because remember, arithmetic sequences are linear and geometric sequences are exponential. So they're going to follow that in their pattern. So for this one, I can kind of guess that it's going to be arithmetic because it seems constant. But remember, our common difference has to be equal, right? The amount we are adding, that common difference has to stay constant for this to be an arithmetic sequence. So a way that I can check and see if it's arithmetic is to find that common difference. So remember, the common difference, if I know that it's arithmetic, the common difference is A2 minus A1. For it to be arithmetic, that has to be equal to A3 minus A2 and A4 minus A3 and A5 minus A4 and so on and so forth. Okay, for it to be an arithmetic sequence, all of these common differences have to be equal. Okay, another way you can do that is to verify that is you can find the common difference. So we know the common difference, if it is arithmetic, the common difference would be 7 minus 3, which is 4. We can check and see, okay, I know 3 plus 4, that's 7. 7 plus 4 is 11, so that checks out. 11 plus 4 is 15. 15 plus 4 is 19, so we can see, yes, this is arithmetic and it has a common difference of 4. Okay, this is not something you need to show on your paper in terms of showing work. You know, you can kind of do it in your head to determine that it's an arithmetic sequence. Now that I know that it's arithmetic, I know I'm using this formula. AN equals A1 plus D times N minus 1. Okay, I can find the general rule by plugging in A1 and D, right? Plugging in A1 and D gives me the formula to find any term of that sequence. Sometimes we call it the explicit formula, sometimes I call it the general rule. So that'll be AN equals 3 is my first term, and my common difference is 4 plus 4 times N minus 1. Right? A1 is your first term, D is your common difference. So now if I want to find A47, A47 tells me that I'm looking for the 47th term. Remember, N is your position in the sequence. So I'm looking for the value of the term in the 47th position. So to find what that value is, I need to input N into my equation. So A47 equals 3 plus 4 times 47 minus 1. That equals 3 plus 4 times 46, and then this I can just plug into my calculator, right? 3 plus 4 parenthesis 46, and we get that our 47th term is equal to 187, and this problem is done. This one, looking at number 2, to me, I can tell that that's not linear. That's not a linear pattern with a constant difference, right? It's going from 1.5 to 6, then jumping to 24, then jumping to 96. I can tell visually that this gap is not equal to this gap. So I'm pretty sure it's not arithmetic. So that's why I'm going to start with geometric in my head and test that first. Okay, sometimes when we have decimals or fractions involved, it's not as obvious, so you have to check both. But that's kind of my thought process here is this doesn't look constant, so I'm going to check for geometric first. So what I do is I remember that r equals, if it is geometric, r is a2 over a1. So I'm going to do that. a2 is 6 because that's the second term divided by a1, which is the first term. 1.5, I do that in my calculator, I get 4. I have two options to check and see if this is a geometric sequence. I can continue to see, okay, is a3 over a2 equal to 4? Is a4 over a3 equal to 4? That's one way to do it. Or you can, again, like we did in the last one, just multiply by 4 and see if you get, the sequence. So we know 1.5. We know 1.5 times 4 is 6. 6 times 4 is 24. 24 times 4 is 96. So we can see that that matches, and this is indeed a geometric sequence. That tells us that we are working with the following formula, right? We're working with the geometric formula. AN equals A1 times R to the n minus 1, where A1 is the first term, R is your common ratio, and n is your position, and AN is the value of the term at that position. Okay? Looking at this, I can find my general formula, my explicit formula, by just plugging in A1 and R, right? This formula would allow me to find any term of this sequence. Then I'm specifically looking for A10, and remember with geometric, I'm going to have to ask for pretty small values. You technically could multiply by 4 10 times, and that wouldn't be too difficult. But it's the idea of working with this formula. A lot of times when I'm just asking you to find a term in a geometric sequence, it has to be a smaller term because it's exponential and it grows so quickly. However, we're practicing with the formula, getting used to the formula, because we're going to have to use the formula for some of the later questions. So make sure that you aren't just like multiplying by 4 in your calculator, right? Someone in 4th grade could do that. We want to actually practice with the formula to become comfortable with what all the variables mean, work with it well, and all of that, so that we are ready when we see the harder problems. So when I'm looking for the 10th term, I'm looking for A10. That tells me that n is equal to 10. I'm looking for the value of the term in the 10th position. So I do that by plugging in 10 to my formula. So then that's going to be 1.5 times 4 to the 9th. Okay, if you type it just like that into your calculator, it should be all good. So long as you put parentheses and all that, you should get an answer straight out. And we will see that the 10th term is 300,093,216. And then this one is done. So for this one, we're told that A13, the 13th term, is 210, and A27, the 27th term, is 112. And we're being asked to find the 80th term of this arithmetic sequence. Now, this piece right here where I tell you that it's an arithmetic sequence is necessary. If that was missing, you would not be able to solve this because you wouldn't know if you're looking for the 80th term of something arithmetic, so we're using that formula, or geometric. There's no way, given the information we have, to determine which of those it is. But because I know it's arithmetic, I know that I'm using this formula, right? And I want to start, I'm not sure where to start here, right? You guys probably aren't either, because you're given a new set of new pieces of information that you've never started with. So when you're given a question and you don't exactly know the path to answering it, you always start with kind of what it's asking for and then work backwards to fill in the pieces. So this is asking for the 80th term. That means it's when n equals 80, right? So at the end of this, eventually, we are going to need to solve this, right? We plug 80 in for n and we find the 80th term. But to do that, for that to be doable, we need both A1 and D, neither of which we have. So I'm going to tell you guys to start by finding the common difference. We're going to look for this first. And the way that we're going to find it is use a little bit of logic from the pieces of information we have. So I want to find the common difference. And I know that my 13th term is 210. And then we got my 14th, 15th, 16th, 17th, 18th, 19th, blah, blah, blah. 26, and my 27th term is 112. First thing, I know that my common difference should be negative, right? I can see that it's getting smaller. So now I need to figure out what it is. Well, we know that a common difference, you're adding the same amount each time, right? We're adding the same amount. Well, to go from the 13th term to the 27th term, we are going to add D a total of 14 times, right? And repeated addition is multiplication. So from the 13th term to the 27th term, we will have added D 14 times. So I'm going to put 14D there. The amount we're jumping from 210 to 112 is negative 98, right? We are going negative 98 over 14 terms. But we know that the common difference has to be equal, so we need to cut up negative 98 into 14 equal pieces. What math operation allows us to take a number and divide it up into equal pieces? It's division. So the way that I'll find my common difference is I'll do negative 98 divided by 14. Okay? The formula for that, we could do 112 minus 210 divided by 27 minus 13. Okay? That gives us negative 98 over 14, which gives us that our common difference, negative 98 divided by 14, is negative 7. Okay? So now we know our common difference. We know our common difference is negative 7, but now we still need A1 to be able to find the 80th term. So I'm just going to work backwards. I could technically, just add 7 a bunch in my calculator, but that's very painful. We don't want to do that. We want to use the formula. So I can use the fact that I know the common difference is negative 7, and I know that one of my terms, I can use either one. I'm just going to use the first one, is A13 is 210, which means that when my input, when my position is 13, when n is 13, my output is 210. That allows me to set up the equation 210 equals A1 minus 7 times 13 minus 1. And then that I can do negative 7 times 12. I'll get 210 equals A1 minus 84. Add 84 to both sides, and I will get that A1 is 294. So then I can plug that in here, and then I can find A80 by just simply typing this into my calculator. So 294 minus 7 times 79. Do that in my calculator, and I will get that A80 is negative 259. Okay, and it makes sense, right? Because our numbers are getting smaller and smaller and smaller, so they're going to go into the negative direction. And now this problem is complete. So for this one, and for ones where you're not exactly sure what steps you have to do, I always like to start with what I'm going to have to do in the end. At the end of the problem, I knew I was going to find the 80th term. And how do I find the 80th term? By plugging in 80 for n. But to be able to solve that, I needed both A1 and D, so I used the pieces of information I had to find A1. This one is not actually anything too difficult, but since it presents the information in a little bit of a different way, I wanted to go through it. So this one says A1 is 1/3, R is 6, and I'm asking you to find the 8th term. Now, in this one, I did not tell you if it's arithmetic or geometric. But unlike the first geometric one where we could, find the common ratio and determine it to see that it's geometric, this one actually just tells us right out of the bat, like, hey, R is 6. You're working with a geometric sequence. So we know right out the bat that we're working with this formula. We don't have to put any thought into it. We don't have to discover R. It's just given to us, right? It can't be a arithmetic sequence if it has a common ratio, okay? So I know my formula, it gives everything to me, is going to be 1/3 times 6 to the n minus 1. Okay, I'm looking for the 8th term. When I'm looking for A8, that tells me that I'm looking for the value of the term in the 8th position. So n is an 8. And so I just plug 8 in to my formula, 1/3 times 6 to the 7th, and then this I just type right into my calculator, being careful to keep 1/3 in its own parentheses and 6 to the 7th in its. And we will have 93312 is my 8th term. And this one is done. Okay, so actually pretty straightforward, but sometimes when the material is presented in a little bit of a different way, it trips us up. Hope this video helps you with the homework and to understand this learning target a little bit more.